Brought to you by Chemistry.
Hello and welcome to Brought to you by Chemistry with me, Dr. Alex Lathbridge. Today is the final episode in our series on air quality, and what better way to conclude something like this in a light-hearted way? Let's hear about the connections between climate change and air quality. Two main questions: are the problems connected? And are the solutions as simple as we might think? Joining us today are two experts within those fields, so let's hear from them.
My name's Sean Beevers. I'm a reader in atmospheric modelling. I work for the Environmental Research Group, and that's part of the School of Public Health at Imperial College in London.
Yeah, hi Alex, hi everyone. So I'm Steve Arnold. I'm a Professor of Atmospheric Composition at the University of Leeds. And I guess my background is in understanding how things are processed in the atmosphere chemically, how they're moved around by the winds, etc., and interactions of those processes with climate and air quality.
Ooh, I like that. I like the introduction, and you told me like what you do sort of day to day. I like that. So Sean, come on, you gotta come back with that. Tell me about what you're currently working on. Tell me about your work. I want to know about that.
Yeah, so my work's split into two main areas. One's related to policy. So I've been working for many years with the Greater London Authority, testing some of their air pollution policies, really from congestion charging all the way up to the ultra-low emission zone, which has been in the news quite a lot recently. And we also undertake research into the exposure of people to air pollution in different health endpoints, so looking at the associations between air pollution and health. And what we're most interested in at the moment is looking at the co-benefits and potential trade-offs between net zero policies and air pollution.
Okay, give me like a tiny little snippet of that. What are some nice trade-offs there? What are some balances? What are some trade-offs? Hit me with that.
So we're really interested in looking at the impacts of introduction of electric vehicles and also changes to sort of heating for domestic residences or commercial buildings. And one of the sort of trade-offs for electric vehicles, for example, is that even though they reduce CO2, obviously, which is the main aim of introducing electric vehicles to the fleet, they potentially increase non-exhaust emissions of PM. So things like tyre wear, road wear, and resuspension.
You know what? That's quite interesting, because with like the whole ULEZ and everything go around, you hear lots of different pieces of information. So I quite like hearing that sort of the balance there. It's quite interesting to me. And, you know, when we talk about like electric vehicles, for instance, the thing that I think about is sort of us moving away from fossil fuels, you know, tackling climate change. And I suppose this is one for you, Stephen, a bit more. Like, could you sort of explain how air quality and climate change are linked?
That question might require an answer which is very long, but I'll try and summarize. It's very complex, I guess. So, and it's definitely a two-way street. So we know that certain air pollutants affect climate. So if we think about species that are emitted directly, for example, like particulate matter, we know that that can cool the local climate because it scatters sunlight, cools the surface. Small particles are also involved in the formation of cloud droplets, which means that, you know, if you change the number of particles in the atmosphere, that will change cloud properties, which will reflect more or less sunlight back to space. So that will affect climate. And then, of course, we have the greenhouse gases. So I guess most of us think about things like CO2 when we think about greenhouse gases, but there are also other greenhouse gases which are more short-lived and take part in chemical processes in the atmosphere. And we tend to think of those as air pollutants as well. So ozone is one example. So tropospheric ozone, which is formed near the surface, is an air pollutant. It's bad for you. It's bad for the respiratory system, but it's also a greenhouse gas. So certain air pollutants can affect climate directly. And then on the other side of the street, in the other direction, then, you know, changes in the climate system, changes in weather patterns will also affect air pollution. So there's a number of ways that can happen. One, I guess, perhaps one of the most obvious is changes in weather patterns themselves, or, you know, wind patterns, precipitation, changes in cloud cover. All of those things can affect the processing of pollutants in the atmosphere, how they're distributed. and where they might meet individuals or meet their kind of endpoints in terms of having an effect. There's also other ways, for example, with regard to natural emissions. So there are certain components of the Earth system where changes in environmental parameters will affect emissions that are coming from the surface. And that might be things like dust. So if we change wind patterns, you might change dust emissions. I guess one of the most obvious, which is a very big topic now, are fires, vegetation fires, forest fires, where we know that a warmer, drier climate in certain areas of the world will manifest in bigger, more extensive fires with higher emissions. So certainly places like the Western US, places like Siberia, Canada, very recently, we're seeing increases in air pollution coming from fires. And there are also kind of more interesting chemical processes happening. So the biosphere is also a huge source of reactive carbon. So there are very reactive molecules, hydrocarbon molecules, that are emitted from vegetation. And those emissions are very dependent on things like temperature. So as we change the climate, there is a response in the natural biosphere to emit more reactive material into the atmosphere, which affects air pollution. So I can go into more detail on that as you wish, but that's a kind of summary anyway of the main interactions.
I mean, that was a pretty good summary. You were definitely right. It's really complex there. Yeah. And sort of that link between climate change and air quality, sort of this two-way street, this back and forth and back and forth. But in between that, there are us humans on here on this planet. And I suppose my question for Sean there is is air pollution and climate change, and is it impacting our health? I feel as though that's an obvious question, and the answer is yes. So I guess my follow-on question, what is really my main question, is how is it happening? And do we have evidence for this?
Okay, so yes, you're right. The answer is yes. The evidence of the impacts of air pollution is actually growing. So what happens periodically is the World Health Organization and other organizations kind of review the science in its totality. So look at the scientific evidence from around the world and then draw a view as to where the health evidence is for air pollution. And the WHO, the World Health Organization, recently did this and produced a report in 2021, which showed not only is the health evidence getting stronger for air pollution, but it's also getting stronger for effects that are at lower and lower concentrations. And so much so that they actually revised, they produced sort of guideline and target values, which other sort of states around the world use in their air pollution policy. And they revised their targets down considerably. So PM 2.5, for example, which is one of the pollutant with probably the strongest health evidence, was revised down from 10 micrograms down to 5. And for nitrogen dioxide, went from 40 micrograms as a standard right the way down to 10. So the evidence is growing for all of these things. And it's one of the biggest environmental issues in relation to health, I think, air pollution. From a climate point of view, I mean, the health effects not only are linked to air pollution, as Steve described earlier, but obviously it's got a much wider sort of health aspect to it. So we're talking about extreme weather events, heat itself, the high temperatures have effects on people's health, water-related health impacts, vector-borne diseases, food production, malnutrition, sea level rise. There's a huge list of climate-related health problems. So from both aspects, from the air pollution and the climate aspects, there's certainly a need to sort of work very hard to reduce and minimise these impacts.
I think one thing that's interesting is the intersection between heat and air pollution, because we know during events where we have heat waves, for example, very extreme temperatures, even in the UK, we know that those heat events tend to coincide with periods when air pollution is also high, right? So the very warm conditions that we have, even periodically for a few days, usually would lead to enhancements in air pollution concentrations. And part of that is because of the reasons I described earlier, where maybe you have very clear skies, very still weather with not much wind going on, very sunny conditions that are conducive to atmospheric chemistry processing. So it tends to lead to enhancements in air pollution. And I think, as Sean just indicated, the heat stress health effects of climate are becoming well understood, I think, and also air pollution, the evidence to support, the fact that if you're exposed to air pollution, especially in the long term, you will have a higher risk of developing certain health conditions. I think that evidence is also getting stronger. I think perhaps where more work is needed, and maybe, I don't know if Sean would agree with this, but is at that intersection where, the combined effect of heat and air quality, I think, is somewhere where, we need to get a better understanding, I think, in terms of how dangerous that combination is during these periods.
I entirely agree with Steve's point there. I think there are a number of things that need to develop, I think, in terms of exposure of people to air pollution and potential exposure of people to heat. So, as he rightly points out, heat and air pollution often coincide. I mean, forest fires, for example, happen at the points where there's very high temperatures. And so you get these huge peaks of PM, and you also get these very high temperatures. And so disentangling which of the effects, are really causing some of the health issues is going to be a challenge. But also you need to look at what people's exposure is to some of these pollutants and some of this heat, and what we're working towards in the air pollution community is trying to determine much more what people's actual exposure is rather than just what the ambient air pollution concentration is. So we want to know what the air pollution and the temperature is inside, because you spend a lot of your time inside. You spend virtually all of your time inside, mostly. And so that's the way we're moving in looking at people's exposure to air pollution. And what has to be coincident with that is the sort of epidemiological methods which look at, we're looking at a health outcome and seeing whether PM or whether temperature or whether some other factor is actually a determinant of that health outcome. That sort of epidemiology study has to sort of develop in the same area. So use these different metrics of exposure, these different metrics of temperature in order to study these events. And I think, it's kind of an area that's developing quite rapidly. And I think it's an area that will be researched for the next decade to come, really.
Looking at that, continued research, like you say, in the next decade to come, obviously, as we move forward, as society moves forwards, as the world moves forward, we're trying to solve the problem of climate change. Do you think that with that back and forth, between air quality and climate change, how they're linked and how they affect one another, will our efforts to tackle climate change impact air quality, like in a hopefully positive, but also could it be a negative way? Please tell me it's positive.
So, the short answer is it's likely to be positive. I mean, if you implement emission control policies that are designed to reduce combustion of fossil fuels or improve combustion efficiency of fossil fuels, then that will likely lead to reductions in emitted air pollutants, right? I mean, that's a kind of very basic assumption, but you're right that there is nuance and there are subtleties to those interactions. So I guess one thing we know is that if we target emissions of the constituents that are most harmful to our health, which as Sean mentioned, is particulate matter, PM2.5, these very small particles. If we implement measures that very rapidly control those emissions, actually the near-term effect of that on climate will be a warming, which might sound counterintuitive, but it relates to the point I made earlier, which is that particulate matter in the atmosphere is scattering radiation. It's providing a kind of cooling, right? And the lifetime of those particles in the atmosphere is very short. It's about a week on average. So if we were to, immediately shut off all particulate emissions from, motor vehicles and power generation, let's say, then, we would very quickly see an improvement in air quality, but we'd also see a response in temperatures because we're removing some of that cooling effect from the atmosphere. And of course, most of the warming is coming from CO2, right, which has a very long lifetime in the atmosphere. So we're removing that cooling effect from particles, but the CO2 is still there, still giving us a warming effect. So in the near term, we'd expect a warming. So I guess you can have a debate about whether, I guess we would never consider this because it's crazy, right? But, you could argue, oh no, we should keep particulate matter in the atmosphere because we don't want to have rapid warming in the near term. But I guess the argument should be that, the massive benefits we'd expect to public health from reducing PM have to be prioritized because we know that the real warming over the long term is really dominated by the CO2 anyway. So I think, that policy interaction is interesting, but I think we've seen that in Europe and North America especially, we've had a prioritization of that kind of, improvement in air quality from pollution control measures. Whether the kind of co-effects on climate have been considered adequately, I don't know. I mean, I think that's still a kind of growing realization that these two things need to be considered together, I think.
We talk about these back and forths, and I've heard the terms co-benefits and trade-offs when talking about this. And I suppose both of you have an answer for this, but maybe look at it in a different way. But what do we mean when we say like co-benefits and trade-offs? Let's start. I'm going to start with you, Sean.
So a co-benefit. So if you're aiming to tackle climate, for instance, so your policy aim is to reduce CO2 emissions for good reason, and as a consequence of that, you reduce air pollution and improve people's health, by reducing PM or by reducing NO2, then that's a co-benefit. It wasn't necessarily your first intention, but it's something that you benefited from all the same.
Oh, I like that. Steve, hit me with some trade-offs then.
So trade-offs is the opposite, where you implement a policy designed to achieve a certain outcome, for example, reducing CO2. But what happens is that measure that you introduce to reduce CO2 leads to a negative impact on something else. So that might be an increase in air pollution, for example. So that would be a trade-off. I guess a good example of that is, again, Sean probably knows a lot more about this than I do, but a good example of that is, there was a policy in the UK to give tax breaks to ownership of diesel because diesel is more efficient and it emits less CO2 per kilometre driven. So there was a kind of encouragement for people to take up diesel vehicles. So vehicle excise duty was lower on diesels. But of course, diesels are much worse in terms of their emissions of particulate matter and also of nitrogen dioxide. So that led to partly led to a kind of a worsening of air quality because there was a larger penetration of diesel into the car fleet. So that would be a kind of trade-off, I guess.
Sean, you look like you have something to say on that. Like, as soon as he said diesel, you sort of went, okay, so I have to be very, very, very clear when I follow on with what I'm about to say next. What are you about to say next?
Well, I mean, Steve's right. It's a really good example. So, Europe generally dieselized their fleet for the benefit of climate for perfectly good reasons, but because diesels, as he said, emit more NOx, they emit more particles. We had a slowing down of the improvements of air quality.
That's a better way for it, isn't it?
And then, and all encapsulated within that, it became the VW scandal, of course, where they were trying to use were using defeat devices to try and pass sort of regulatory tests, whereas the actual on-road performance of diesel vehicle was considerably worse than the test would show. And so, we had measurements, and they were absolutely critical in identifying this as an issue. And eventually, a number of tests were undertaken, and of course, it all became public knowledge. And I think everybody knows the story after that. Looking
at things that were done in the past, and now looking at work to think about the future. Sean, are there any types of modelling that that we have available now that we can do that can aid us in predicting the quality of air for the future? And that might help when we think about policies to put in and whatnot.
Yes, there are. I mean, that's essentially what my job is. So
that's good.
So we use a couple of types of model. We use a model called the chemical transport model. It's sort of describes as best it can the physics and the chemistry of the atmosphere and the processes therein. And we use that with meteorological data, which is also from a model, and emissions data from all the different sources that we have information for. So we try and capture all of those. And that gives us air pollution concentrations at quite a large area, sort of up to sort of continental scale. What happens then is you sort of nest down with ever increasing detail towards the area that you're really interested in. So in our case would be the UK. And what you end up with is a model that can give you hourly concentrations of the sort of pollutants that you're concerned with, up to a 2 kilometre scale, so sort of background air pollution concentrations. So then what we do is we superimpose on top of that a little sort of road scale model, and that gives us the sort of detailed air pollution concentrations from your local road network, which aren't really encapsulated well by a 2 kilometre scale model. And that gives the very, very sharp differences between air pollution concentrations close to road and also not very far away. So we get all the way down to sort of scales of the order of sort of tens of meters, really. And that's a much better description of what people's air pollution exposure is. And then on top of that, we have an indoor model, which is we sort of exchange outdoor air pollution indoors and include indoor sources within our indoor model. And then you can actually determine what people's exposure is indoors as well. And so you can use those models and you can make future forecasts, particularly the outdoor one is the most common one to use. You change your emissions forecast, you can change your meteorological forecasts, you can test different policies for different time horizons for different years in the future. It could be 2030 or 2040. And then you get a concentration, a new concentration, and that's your future forecast. And you can look at your model uncertainty, and you can test a number of different policies in order to get a sort of coherent story of how whatever policy you wanted to test, be it about climate change or about air pollution on its own, what effect it's likely to have on people's exposure, and then you can actually calculate the health impacts from those models.
If we didn't have models, what would you do? What would your other job be?
I don't know. I've no idea. I quite like sailing, so I'll probably be a sailor.
I'll just sack this off. I'm going to go on a boat.
Yeah, I'll go and sail a boat.
Right now, we are finding it more and more important to focus on air quality and climate change, taking those actions, making change. Now, from your work, from your modeling, I don't want to say, hey, in the future, things are going to get massively better. Everything's going to be great. Everything's going to be fantastic. Me, and by extension, the Brought to You by Chemistry listeners want to know, do you expect to see different types of pollution in the future? Not necessarily no pollution, but maybe different types? Are we moving on to what's the future of pollution? Ooh, that's a good album title, Future of Pollution.
That's a very good question. And I guess this is where we do rely on the models, right? So, the models are the only tool we have that can process all the information we have on what might happen to climate in future, weather patterns, temperatures, precipitation, and then also Sean said, taking in the emissions data that we have about what policies might mean for emissions of different constituents in the atmosphere from different sources and different locations. So the IPCC actually, as you know, and listeners are probably well aware, the IPCC undertake their multi-model climate model assessment. So they run all the world's different climate models with exactly the same information fed into them. And then, those, I guess, they're best known in terms of their use in predicting future temperature, future sea ice, future sea level rise, et cetera, et cetera. But actually more recently, in the recent IPCC assessment, more processes were included in those models that are capable of simulating atmospheric chemistry and considering things like air pollution emissions and the processing of that air pollution in the atmosphere. So the first thing to say, I guess, is that these models are very large scale compared to the models that Sean was describing. So, you're not going to get how is air pollution going to change on, in Trafalgar Square in 2050 compared to present day, because they're not capable of resolving that amount of spatial detail. But what they do allow us to do is get very long-term simulations, over multi-decades, thinking about how the background air pollution is evolving in response to different policies. So we've done some work using output from these models and looking at things like the World Health Organization targets that Sean was mentioning earlier for particulate matter in particular. And we've also looked at kind of co-benefits, as we discussed earlier, with regard to different climate policies and what they imply for air pollution exposure. And then we can also do health impact assessment modeling, similar to Sean, to translate those changes in particulate matter to essentially to health impacts. And generally we use premature mortality when we quantify that. So what we see anyway, so to get to the answer, what we see from these simulations is that if we apply a kind of a strong decarbonisation scenario in the future, so that would be consistent with a 1.5 degree or 2 degree global mean warming by 2100. And then we compare that with a kind of, middle of the road 3 degree warming. If we do go for that more stringent emission control to achieve that lesser warming target, then actually that results in a strong co-benefit to public health from air pollution. And that's because those very stringent emission control policies are not only reducing CO2 emissions, they're also reducing emissions of air pollutants. So actually by 2050, relative to a kind of standard scenario, these very strong decarbonisation scenarios could prevent about 3 million deaths a year due to air pollution.
Well, this is a question for both of you, but let's start with you. Are you hopeful that major cities in the UK can improve their air quality? I was going to say around the globe, but let's start in the UK. Are you hopeful that major cities can improve their air quality?
I mean, are you asking me? I mean, I think we already are, right? I mean, we already have. I mean, if you look at NO2 as an example, then there's been a lot of to and fro, a lot of problems in the UK specifically with NO2, and Sean knows a lot more about that than I do. But that it is coming down, it has come down quite markedly. So in terms of exposure to NO2, nitrogen dioxide pollution, most city centres in the UK have improved their position compared with, say, 10 years ago. And in fact, what we've seen in a couple of cities, at least two, with regard to implementation of clean air zones, and Leeds is one of them, which is why I know a bit about it. The reason the Leeds clean air zone was eventually not implemented is because monitoring showed that actually, without doing anything, the vehicle fleet had changed to such an extent that the NO2 compliance had actually happened, right? So if you're interested in complying with the UK air quality target for NO2 as an annual mean, then Leeds was already doing that without even implementing the clean air zone. And that's just because people are starting to drive cleaner vehicles.
I think the only thing worth pointing out, especially related to clean air zones, I suppose, is that in a lot of the cities, well, we work sort of a lot in London, so it doesn't meet the sort of WHO targets. So we're using potentially quite old and slightly out of date sort of targets to aim at, and so miraculously we meet them, and then all of a sudden we look at the WHO targets, and they're now, rather than 40, they're now 10 for NO2, and suddenly we're back in the problem area. So it's a sort of, it's perception as much as it is anything else. So I still think there's plenty of work to do. But I think he's right in saying that, the fleet's cleaned up and will continue to clean up, and the introduction of electric vehicles is happening. So that will continue. So for things like for NO2, it is going to improve. But it just means that more is going to have to be done with other sources. So it's going to be the non-vehicle related sources that are going to, we're going to start to look at. And that's kind of why I was pointing to things like heating, because in cities that's going to be a big aspect of improvements to things like NO2, because gas combustion's a source of NOx, and so we have to control that too. And I think one other thing that we ought to sort of touch on is that we mentioned the indoor environment and people's exposure indoors that is becoming increasingly important as part of people's overall exposure. Especially as outdoor air pollution improves, you can get distinct benefits from stopping using gas cookers, for instance, because they're a source of NOx and they're a source of indoor PM as well. But you have to be wary of things like if you insulate your homes and you make your home airtight, that you're more prone to air pollutants that are sourced from indoors, and so you've got to ventilate your homes cleverly in order to avoid these sort of trade-off issues in your home environment. And I think that, for me, that's the thing that's going to sort of bring people along with you in the sort of grand scheme of changing the way in which they do things, buying heat pumps, not using gas cookers and so on. It's kind of making air pollution and health almost like a personalized thing. It's got to be relatable to people. You can talk about meeting air quality guideline standards until you're blue in the face, but nobody really knows what that means or whether it's a good or, I mean, generally they know it's a good thing, but it doesn't really mean anything to their sort of everyday life. So I think, this idea of health and sort of your personal exposure, including the indoor environments, are actually a key part of getting people on board. Telling somebody that if you improve air pollution, it will reduce their childhood asthma, that sort of thing is far more convincing than you're going to meet 10 micrograms PM 2.5 standards. So I think, the public health aspects of it are really important.
Now, with sort of this public health and policy thing in mind, are we actually seeing the benefits of reduction in pollutants? Are we seeing that yet when it comes to like health outcomes, when it comes to public health?
Well, if you do the health calculations, as Steve mentioned, you can do health impact assessments and look at the before and after a policy and work out what the health benefits are, and you can do the costs, and the costs are generally always less than the benefits that you get. You generally see that things are improving, but there's a kind of a whole other sort of area of research, which is where people try to understand what the effects of air pollution are on people's health, and that's sort of said, the increasing evidence is that there are health effects at lower and lower concentrations. So we're kind of we're working towards improving air quality, and at the same time, the air pollution and health research community are sort of saying, yeah, but you need to try a little bit harder. So yes, things are improving.
Amazing. Well, I think that is all for us today. This has been absolutely incredible. Like, thank you both for joining us here today. You've been fantastic. You've enjoyed yourself, right?
Yeah, certainly. Yeah, it's been good.
And that's it for this season of Brought to You by Chemistry. Thank you so much for joining us through this journey into air quality. If you haven't already, then please go back and listen to our previous seasons where we've covered light-hearted topics like plastic pollution, battery technology, and antimicrobial resistance. I've been Dr. Alex Lathbridge, and as always, bye for now.